So first of all, we'll discuss acid, bases, and salt. But what is
Okay.
an acid? What is an base? Acid, that means which have ability to donate proton. Base, that means base or alkali. That means it have a ability to donate OH minus. Okay.
Okay.
If we will discuss the comparative study between the acid and base, and first criteria is taste. That what is the taste of acid and base? It is like sour and it is like bitter. Sensation to touch, it is actually corrosive nature and it can burn skin, but base have a soapy nature, or you can say slippery nature.
Okay, sir.
For example, if you take an example of soap or detergent, in all type of soaps and detergent, actually base are the important component, and that's why soap are slippery in nature. Understood?
Yes, sir.
Now, the physical state of acid can be gases or liquid. Bases, bases have the ability to exist in solid, or you can say in liquid. Reaction with water. When acid react with water, then it produces H plus ion. But when base react with the water, then it produces OH minus ion. pH
Okay.
scale. pH scale, that means the measure to hydrogen ion concentration.
Yes, sir. I know that, sir.
Yeah. So pH less than 7 for acid, pH greater than 7 for base.
Yes, sir.
Solubility. Generally water soluble and
Sir,
base are also, yeah. Tell me.
exact 7 is neutral, no, sir.
Exact 7 is neutral.
That is water or
Yeah, water you can say salt.
yes, sir.
Now solubility. Some are also insoluble, but some are soluble. And the base which are soluble are known as alkali. Okay,
Yes, sir.
that's the basic difference between base and alkali. Like
Yes, sir.
alkali are soluble bases,
Okay.
but insoluble bases are not alkali. Now the classification of acid on the basis of strength. Strength, that means how they actually release H plus ion. If they release H plus ion very efficiently, then acid is known as a strong. Such type of acid example is HCl, HNO3. Weak acid, acetic acid, formic acid, methanoic acid. Such type of acid is weak acid. On the basis of concentration, if the amount of acid in the water is very high, then the solution or acid is concentrated acid. Like in,
Yes,
for example, less water plus more acid. Understood? And
yes,
if you
sir.
see that it is a dilute form means more water plus less acid.
Okay.
On the basis of concentration, it is categorized into two parts, concentrated and dilute. And the third one is molecular composition. On the basis of molecular composition, it is divided into two parts, oxyacid and hydroacid. Oxyacid, that means the acid which contain oxygen. See, here it is oxygen, here it is oxygen.
Yes.
Understood?
Uh,
And the hydroacid, that means it have only hydrogen, not oxygen, like HCl, HBr, HI, and similarly H2S. Understood?
yes, sir.
Such type of acid are hydroacids. Now basicity. Basicity means how they release and how much they release H plus ion. If any acid releases 1 H plus ion, then it is called monobasic. If it releases 2 H plus ion, then it is called dibasic. If it releases 3 H plus ion, then it is called tribasic.
Okay.
For example, basicity, acetic acid, sulfuric acid, and phosphoric acid. Acetic acid, for example, CS3COH, it have only one H plus. HCl, it have only one H plus. HNO3, it have only one H plus. So all the acid have basicity 1. Sulfuric acid, for example, H2SO4. Or you can say take an example of H2SO3. Both have 2 H plus, so it is dibasic in nature. Phosphoric acid, for example, S3PO4, it have 3 H plus. Understood?
Yes, sir. Sir, do we have 4 basics, sir?
No, yeah, 4 basic can be exist, but not in your syllabus.
Okay, sir.
Now, pH of acid and base. So pH, or you can say potential of the hydrogen. Potential of hydrogen
Hydrogen.
in a numeric scale, or you can say negative logarithm. Negative logarithm of the H plus concentration is known as pH. If you define P of any quantity, suppose any quantity you have taken, then it is equals to minus log of quantity. Understood?
Yes, sir.
So if you will find pH, then it will be equals to minus log of H plus.
Okay, sir.
Similarly, a solution, you already know this. pH is less than 7, solution is acidic. pH is greater than 7, basic 7 is exact neutral. Now, universal indicator. You know why pH indicator is known as universal indicator? Because it have a very wide range of 1 to 14, and you can almost you can say that you can check the acidic nature or basic nature of maximum substance by using pH scale, and that's why it is known as universal indicator, because it is actually used for the you can say for testing or for checking whether the molecule is acidic or basic. That's why it is known as universal indicator, because it
Yes,
can be used for acid as well as base for a wide
yes.
range.
Okay,
So
sir.
that's why pH is also known as universal indicator. Now salt. Salt are described as ionic compound. Salt are described as ionic compound which is formed by the combination of acid and base.
Base.
If you will combine acid with the base, then it will form salt along with the water. This reaction is also known as what? Neutralization reaction.
Okay, sir.
Neutralization reaction. Now, formation of salt. Salts are formed due to the chemical reaction between how salt can be formed. First one is a base and an acid. When base reacts with acid, then it forms NaCl. For example, NaOH plus HCl, NaOH plus H2O, so forth. Now, second one is a metal and an acid. When metal is allowed to react with acid, then it also forms salt.
Yes, sir.
Third one is metal and the non-metal, Li plus non-metal. Cl2 is the non-metal, Li is the metal. So when metal reacts with the non-metal, then it forms LiCl. It's LiCl, not LiCl.
Okay.
So it is a salt. It is a salt. And the another one is a base and an acetic anhydride. Acid anhydride means the oxide of the chlorine. So NaOH and Cl2, it will form NaCl. Acid and base anhydride. Basic anhydride means the oxide of base, oxide or oxide of metal, you can say. So
Okay.
you can see here that the salt have been formed. Here also salt have been formed. So salt can also be prepared by double decomposition reaction. We can say here just PbNO3 plus Na2SO4. Pb will exchange their ions with SO4 and NO2 will exchange with the NO3. These
Yes,
two
sir.
are salt. This one is also salt. This one is also salt. So salt can be
Okay.
also formed with the help of other aqueous solution of salt. Now the general properties of salts are, the first one is salt, that means carbonates or hydrogen carbonates like MCO3 and MnCO3. It is carbonate and it is bicarbonate. When they react
Okay.
with the acid HX, then it forms Mx plus CO2 plus H2O. That is, it releases CO2 and H2O. It is a general reaction. For example, if you take Na2CO3 plus HCl, then what will form? NaCl, because here X is Cl. So NaCl plus H2O plus CO2. See, it is a general reaction. If you will remember this, then you can do all type of such type of reaction with the help of this.
Okay, sir.
Okay. Now, type of salt: normal salt, acid salt, and basic salt. Normal salt, which is formed with the help of a strong acid and a strong base.
Okay,
Okay.
sir.
Normal salt is also known as neutral salt. Normal
Okay,
salt is
sir.
also known as neutral salt. Acidic salt, which is formed by the strong acid but weak base. See, a
Weak
strong plus a
base.
strong, it is neutral. A strong
Okay,
plus
sir.
weak, it is acidic. Weak plus a strong, the part which is strong is dominating. Base is strong, so
Yes,
the
sir.
salt is basic.
Uh,
And if you will take both weak, then it will be neutral.
okay, sir.
Okay, so that's the category of the normal salt, acidic salt, and the basic salt. Now, the method of preparation. First one is the direct combination. If you will take the sodium with the chlorine, then it will form NaCl, like metal plus non-metal.
Directly it is
Yeah, direct
combining.
combination. Yeah,
Yes, sir.
aluminium plus Br2L, Br3, it is also a salt.
Combining. Yes, sir.
Now, method of the salt preparation, that is neutralization. Neutralization
Neutralize.
means acid react with the base.
Base.
Acid react with the base. So method of salt preparation, displacement method. Like First one is zinc and sulfuric acid. When zinc is allowed to react with sulfuric acid, then actually zinc, what does zinc do? Zinc actually replaces the hydrogen. See, here it is replacing the hydrogen, and zinc is taking the position of hydrogen. See, and
Okay,
form
sir.
zinc sulfate. It is known as the displacement method. It is known as the displacement.
Displace.
First method was the direct combination. Second method was the
Display.
neutralization,
Neutralization.
and the third method is displacement method.
Displacement.
A
Okay,
similar
sir.
example is taken here. The iron is reacting with the H2SO4. The iron will replace the hydrogen,
So
and it will form
FeSO4 plus
FeSO4. Yeah,
H.
it is salt. So
Okay, sir.
by displacement, you can also form salt. Now the another method is method of the salt preparation, double decomposition of precipitation. You can say precipitation reaction. Yeah,
Sir,
here,
one doubt, sir.
yeah.
Sir, after that iron example, sir.
Hmm.
After H2, they have put an arrow mark, no, sir.
Arrow. If arrow will upward, then it will form that it is formed as gas.
Gas.
If arrow will be downward, then it is formed as a
So,
precipitate.
precipitate. Okay, sir.
Okay, the
Yes,
precipitate,
sir.
or you can say solid. Okay.
Yes, sir.
So here method of the salt double decompose. Double decomposition means suppose PbNO3 go to HCl. So Pb will replace H, okay, and Cl will replace with Pb, like
Okay.
PbCl2 and HNO3.
Yes, sir.
Double displacement reaction. Understood?
Okay, sir. Yes, sir.
So this is the method for the preparation of the salt. That how you will prepare salt, or how you will prepare salt by different methods. So it is
Okay, sir.
all about the acid, base, and salt. Okay.
That's it, sir.
Wait for a while, and the rest of the topic we will discuss in the next slide.
Okay.
Okay. Acid and base, it has also, you can say, assignment. You have to also solve assignment for this one too.
Okay, sir.
Okay, now I'm summarizing the whole concept of acid base in salt.
Okay.
And the topic which is skipped, we will cover it now.
Okay, sir. Acid bases and salt, that's it, no, sir.
Yeah.
Okay, sir.
Okay.
Sir,
First,
I should remember that equations, no, sir.
yeah, you should remember that equation. We have already done the acid part and
Yes, sir.
its classification. We have completed. We have done it. Now, after acid and its classification, another topic is the preparation of acid. Preparation of acid. This part we haven't covered yet.
Yes, sir.
Now we will cover it now. Preparation of acid. So first one is biosynthesis. You can directly combine hydrogen with non-metal. Hydrogen with non-metal.
Non-metal.
And it will form acid. For example, H2 plus Cl2. It is HCl. H2 plus Br2. It is HBr. And both are acid. Understood?
Yes, sir.
Now the second method is by action of water on non-metallic oxide. Non-metallic oxide. So for example, here I'm taking the example of SO3. It is a non-metallic oxide and we are adding water on it. It will form sulfuric acid. CO2, it is non-metallic oxide, we are adding water. It will form H2CO3, carbonic acid.
Okay,
So
sir.
second method was by action of water on the non-metallic oxide. Now third one is by oxidation of non-metals. By oxidation of non-metals. For example, sulfur plus HNO3. Here we are trying to oxidize sulfur by nitric acid. It will form H2SO4, NO2 plus H2O. Now, fourth one is by displacement. By displacement. Displacement means NaCl. Normal we are taking salt and we are reacting with the H2SO4. It will form Na2SO4 plus HCl. See, HCl is formed by displacement reaction. Now, third topic is properties of acid. Properties of acid. We have already covered this part, properties of acid. For example, taste, physical state. Understood?
Yes, sir.
We have already covered this one. Now, after properties of acid, we will discuss the chemical properties. Chemical properties. In chemical properties, the first one is reaction with active metals. Reaction with active metals. For example, when sodium or iron or potassium is allowed to react with acid, and what will form? It will form salt. NaNO3 plus H2 gas, FeCl3 plus H2 gas, K2SO4 plus H2 gas. Understood?
Yes,
That
sir.
is the first reaction. Now, the second one is reaction with base. How acid react with base? When acid react with base, then it forms salt along with water. For example, C. Acid, for example, HCl plus base NaOH, it will form NaCl plus H2. This reaction is also known as neutralization reaction. Understood?
Yes, sir.
Third one is reaction with carbonate and bicarbonate. Suppose calcium carbonate here I'm taking, and suppose NaHCO3 bicarbonate, and we are allowed to react with HCl, H2SO4, what will form? It will form CaCl2 plus H2O plus CO2. It will form Na2SO4 plus H2O plus CO2. Understood?
Yes, sir.
Now the fourth one is reaction with sulfides and bisulfite. CaSO3, it is calcium sulfide. When we react with HCl, then it forms CaCl2 plus H2O plus sulfur dioxide gas will release. Suppose when you take carbonate, then CO2 is released. When you take sulfide, then SO2 is released. Fifth one is reaction with sulfide. Reaction with sulfides. For example, zinc sulfide. When allowed to react with HCl, then it forms ZnCl2 plus H2S. Hydrogen gas is released. H2S sulfide, hydrogen sulfide is released. So this is all about the acid and their chemical properties. Now we will discuss base. Base. So first one is base and its classification. We have already. Now the second one is after base and its classification. The second one is its properties, its physical properties. We have completed this one too, like taste, reactivity, solubility. Third one is chemical properties, or you can say preparation. How will you prepare this? Preparation of base. So first reaction is from metal. How it would form base with the metal. Just allow to react with oxygen. It will form basic oxide. It is basic oxide. Similarly, you can take example of magnesium plus O2. It is magnesium oxide. Second, by reaction of water on reactive metal. For example, Na plus H2O. It will form NaOH plus H2O. Now, third one is by double decomposition. Double decomposition. You can take example of FeCl3 plus NaOH. It will form FeOH whole size. It is base plus NaCl. Fourth one is by the action of oxygen on metal sulfide. For suppose metal sulfide we have, allow it to react with oxygen, ZnO plus SO2. It is basic oxide. So in this method, we can prepare base. Chemical properties is similar to basic property. Now, another topic is pH scale. We have already covered this one. pH scale as a universal indicator. Why it is called universal indicator? We have completed. And after pH, no. Third one is salt. Salt. We know the basic definition. Basic definition we have completed. Types of salt we have completed. Normal salt, acidic salt, basic salt. Preparation of salt we have completed. Preparation of salt. Completed or not?
Yes, sir.
By displacement, by double displacement, by direct composition.
Yes,
Understood?
sir. Understood.
Salt part. Only one thing is left. Laboratory preparation of first one is FeCl3. Second one after FeCl3 is copper sulfur, that is blue neutral. Third one is ZnSO4. Fourth one is FeSO4. Fifth one is PbCl2. Sixth one is calcium carbonate. Seventh one is sodium bicarbonate. Eighth number is N2SO4.10H2O. Similarly, CSO4.2H2O, which is called gypsum. CSO4.half H2O, which is plaster of Paris. So this is all about the preparation, laboratory preparation of such salt. We have already completed this one in previous classes, FeCl3, CSO4, ZnSO4, FeSO4. What you have to do for this revision, okay? Just try to follow this one. First, read throughout this topic from your textbook. Okay, whole part. Okay, you will get the laboratory preparation of salt. You will get this as a separate topic in your salt chapter.
Okay, sir.
In your salt section, like 3B, section 3B. Okay, and when you will go through that one, then you will get the whole syllabus of this one. Okay.
Yes, sir.
Now in the salt part, the last part which is left is water of crystallization, like efflorescence and deliquescence. Have you ever heard about efflorescence and deliquescence?
Yes, sir.
What does mean efflorescence?
Efflorescence, sir. I think it is the crystalline deposit, sir.
No, do not like that. So first we will see water of crystallization. Water of crystallization means when any salt is formed, when any certain salt is formed, then some amount of water molecule gets trapped with it. It is called water of crystallization. Water of crystallization. For example, copper sulfate dot 5H2O. It has 5 water molecules. NO2CO3 dot 10H2O. It has 10 water molecules. LiCl dot 2H2O. It has 2 water molecules. This is known as water of crystallization. Understood?
Yes, sir.
How will you detect whether the salt have water of crystallization or not?
We will condense it, sir.
We will condense or heat?
Heat, sir.
Okay, to check water of crystallization, we heat the salt. If any water will evaporate, then there must be water of crystallization. Understood?
Yes.
Now, whatever the PDF notes I am actually sending you, or ma'am is sending you, try to save all those PDF in separate form in 2 or 3 places, like in pen drive, in PC, in mobile, so that you don't have any problem in future.
I have saved it, sir, which you have sent it right now.
No, actually you will say in future that my computer got corrupted, everything is clear, everything is not this and that. Now please send me. In that case, I won't be able to send all those PDF. Okay. So try to save it. It's your responsibility, not mine.
Okay.
Now, We have to learn some the common name of all the salt, like washing soda. Washing
Yes,
soda
sir.
is Na2CO3 dot 10H2O. 10H2O. You have to
Okay.
learn all this formula. Epsom salt.
Okay,
Epsom
sir.
salt is MgSO4 dot 7H2O. Third one is potash Lm. Potash Lm. K2SO4 Al2SO4 whole thrice dot 24H2O. Now, Glauber salt. Glauber salt is Na2SO4 dot 10H2O.
Sir,
Another one is
NaCl is what, sir?
NaCl.
Cl.
NaCl is table salt.
Table salt. Okay, sir.
Blue vitriol. Blue vitriol is copper sulfate dot 5H2O. Plaster of Paris. Plaster of Paris is calcium sulfate dot half H2O. White vitriol. ZnSO4 dot 7H2O. Gypsum. Calcium sulfate dot 2H2O. Learn all this formula of the common name.
Okay, sir.
Now we will see efflorescence. Efflorescence, it is a property. It is a property of some salt, of some substance to lose wholly or partly their water of crystallization. Water of crystallization, when their crystallization, or we can say when their crystal are exposed to, when their crystals are exposed to dry air. Understood? This is known as
Yes, sir.
efflorescent substance. When they are exposed, then they just lose the water. For example, Na2CO3 dot NH2O, it is washing soda. And when it is kept in dry air, then it loses some molecule of water and it forms H2O plus 9 water. It actually loses 9 molecule of water. When you take Na2SO4 dot NH2O, global salt, and when you hit dry air, then it completely loses its water molecule. So it is a partly and it is wholly. Understood?
Yes, sir.
It is efflorescence. Now, another one is deliquescence. Deliquescent substance. Certain water soluble substance when exposed to atmosphere at ordinary temperature, then it absorbs moisture. It absorbs moisture from the atmosphere. Understood? It is deliquescent substance. For example, NaOH, KOH, MgCl2, ZnCl2, etc. These are the substances which absorb moisture from the atmosphere. Understood?
Yes, sir.
So now we have completed the revision part of acid, bases, and salt.
Okay,
Okay.
sir.
Now the
Yes,
first
sir.
chapter is the periodicity. We have completed.
Yes, sir.
Second one is chemical bonding. We have completed.
Yes,
Third
sir.
one is acid, bases, and salt.
Acid, base, salts.
We have completed. Fourth one is analytical chemistry. We have completed.
Yes.
Understood? Now there
Yes,
are
sir.
only two chapters left for the revision, more concept and the
Stoichiometry.
electrochemistry. electrochemistry.
Electrolysis.
Yeah, electrolysis. Okay, only 2 chapters is left now. So we will discuss in the next class. Okay.
Okay, sir.
Next class.